All right, welcome back, everyone. So far, we've covered the theory. Now, in part 4, it's time to get our hands dirty. We're going to move from just talking about dimensional analysis to actually using it, turning it into your secret weapon for absolutely crushing those NEET problems.
So, what's on the menu today? First, we'll do a super quick recap of the core ideas. Then, we'll build out your problem-solving framework, your go-to plan. After that, we'll dive into some real NEET-style problems. And of course, we'll talk about the common traps to avoid and, my favorite part, how to use all this as a super fast shortcut.
Okay, first things first. Let's just do a quick memory jog on the one big idea, the one core principle that makes this whole thing work. Okay, this right here, this is the golden rule, the principle of homogeneity. All it really says is that any physical equation that's legit has to be balanced dimensionally. I mean, it's common sense, right? You can't add apples and oranges, and in physics, you can't add meters to kilograms. The units on both sides of that equal sign have to match up perfectly.
And from that one simple rule, we get two really powerful applications. First, we can use it to check if an equation someone gives us is even possible. And second, which is super cool, we can actually build a relationship between different physical quantities from scratch. All right, now for what I think is the most important part of this whole session. We're going to build a universal blueprint, a step-by-step guide that you can use to solve pretty much any dimensional analysis question they throw at you. So let's dive right in.
Look at this. This 5-step process, this is your game plan. It takes all the guesswork out of it. Step 1, identify what you're looking for. Step 2, set up the relationship. You get the idea. Seriously, burn these steps into your brain and you'll always know what to do next. We're going to follow this exactly in the next few examples.
Okay, enough talk. Theory is great, but it's time to see how this framework actually works in the real world, or at least in the world of NEET problems. Let's solve one together, step by step.
So here's a super classic problem type. They'll give you some equation, maybe one you've never even seen before, and they'll ask, hey, is this dimensionally correct? Our job is just to put it to the test using our golden rule.
Okay, here's a little pro tip that you have to remember. When you see functions like sine, cosine, log, anything like that, they're a bit special. Think of them as machines that only accept pure numbers. That means whatever is inside those parentheses, what we call the argument, has to be completely dimensionless. No units allowed.
So let's check the argument here, which is v times t. We know the dimension for velocity is L t to the minus 1, and the dimension for time is just t. When you multiply them, whoops, the t's cancel out, but we're left with L for length. Is length dimensionless? No way! So because the argument isn't dimensionless, the entire equation is wrong. Boom, done.
Okay, that was checking an equation. Now for the other big one, deriving a formula. This is where you really feel like a physicist. We're going to use our 5-step framework to build the formula for a simple pendulum right from scratch. This is a crucial skill, so pay close attention.
All right, following our plan, step 1 is just to get organized. Let's list out all the players in this problem. The time period t, the length L, the mass m, and gravity g. And for each one, we'll write down its dimensional formula. This just sets us up for success.
Okay, now for step 2. We set up the basic relationship. We're just going to say that the time period, t, is proportional to length raised to some power x, mass to some power y, and gravity to some power z. We don't know x, y, and z yet. That's what we're here to find. Then we just plug in the dimensional formulas we just wrote down and start tidying things up, grouping all the m's, l's, and t's together.
And now we use the magic of homogeneity. The power of m on the left has to equal the power of m on the right. Same for L, same for t. This gives us 3 little equations. On the left, there's no m, so its power is 0, which means y has to be 0. For t, its power is 1 on the left, so minus 2z must equal 1. And for L, well, you see how it works. We just solved this simple little puzzle.
And here it is, the big reveal. We plug those exponents we just found back into our equation. And look at that. The exponent for mass, y, was 0. M to the power of 0 is just 1. What does that mean? It means mass doesn't even affect the time period of a pendulum. How cool is that? We just discovered a real piece of physics using only dimensions. We're left with t being proportional to the square root of L over g. See? It's not so bad. You can totally do this. Okay, so knowing the framework is awesome, but it's only half the battle. Now we need to talk about the sneaky traps and common mistakes that can trip you up and cost you easy marks. Let's make sure that doesn't happen to you.
So,
where do students usually go wrong with this stuff? Let's just face it head on. If we know where the traps are, we can just walk right around them on exam day, right?
You've got to be super careful with these. First, don't forget that plain old numbers, like pi, or 2, or a half, they don't have any dimensions. They're just numbers. Second, never ever violate the golden rule by adding or subtracting things with different dimensions. Third, remember our pro tip about functions like sine and log. The stuff inside has to be dimensionless. And finally, read the question. Make sure you know exactly what each variable represents.
All right, for our final section, let's talk strategy. This is where dimensional analysis goes from being a problem-solving tool to being a full-on exam superpower. I'm talking about using it as a shortcut to save you precious, precious time.
This, right here, is the ultimate game changer for multiple-choice questions. Think about it. In an exam like NEET, you don't always have to build the right answer from scratch. Sometimes it's way, way faster to just prove that the other 3 options are impossible. I mean, just look at the comparison. You could spend, a minute or 2 doing all the algebra to derive a formula? Or you could spend less than 30 seconds just checking the dimensions of the 4 options they give you. If the question is asking for energy, for example, any answer that doesn't boil down to ml squared t to the minus 2 is just flat out wrong. You can eliminate it instantly. It's not just faster, it's often safer because there's less chance of a silly calculation mistake.
So please, remember this. In an exam like NEET, being fast is being accurate. So make dimensional analysis your first line of attack, your first check, not the thing you do when you're totally stuck.
So, I'll leave you with a final little puzzle to think about. This tool is incredibly powerful, right? But it does have limits. What kind of formula would be totally impossible to figure out using only dimensional analysis? I'll give you a hint. Think about equations where things are being added together. Ponder on that. Keep practicing these steps, keep solving problems, and I promise this will become second nature.